Hello and welcome back to the Winning at Blackjack series. Today we are on episode 4 of the Blackjack series. Today is going to probably be the longest episode of the series, so make sure you pay attention throughout so you can really understand the complexity we're going to get into. Last video we went through creating our function that determines the value of the hands and sorting out potential blackjacks and insurance in the game. Today's episode we have a lot to cover, starting off with using a blackjack basic strategy chart to determine the decision of the players and the NPCs. Obviously the other players on the table won't have perfect strategy in real life, however this was the most realistically we're going to get. The other players are shown to not make any significant differences in the long run anyway. Then, once all the players have finished playing, the dealer will then play. Once the dealer has played, we will finally determine who wins money and who loses money. So, let's get straight into it. Starting off from last video, we used blackjack variables. We will want to create a new if statement. If it is not dealer blackjack nor player blackjack, meaning the hand will be played with, we want to start by initializing two variables. Amount, which will store the value of the hand we end up with. We'll set that to 0 for now. And double down, which is just a Boolean variable that will tell us after the function if the player doubled down or not. Now let's call this function. From the function we want to receive the amount the hand is worth, the cards left in the shoe, and whether the player doubled down. So the function we're calling is going to be called players, which we will be sending the variables cards left, player's hand, and dealer's reveal card to. So to begin, we create the function. Def player, cards left, hand, dealer. Now a loop that will repeat until we hit a return function in the function, while true. Let's get the value of the hand first. By using the value function we created in the previous video, we're going to need to add a new thing to our value function. We must determine if the hand is a soft hand, has an ace or not. So to do this, we just need to go into the function and write soft equals, then the truth statement, aces is greater than or equal to 1. Then placing the soft variable in the return. This does now, however, mean we will have to go and place a filler into any of the times we have called value function before. Now back to the player function. We do valuation, comma, soft equals value hand. Let's begin with the easy part. If we are over 21, then we busted. So we will just turn the valuation, cards left, and confirm that we are not doubling down. Getting into our basic strategy now. So how we're going to do this is using a dictionary. We use a key that will involve the value of our hand, the dealer's up card, and then give it a value, which will be the action we will be doing. So the example I will show for this is if we have a hand that is 14 and the dealer's up card is a king, then our key would look like brackets 14, comma, K. Basic strategy would say to hit, so then we do brackets, colon, hit. We will need to write this for every possible position we could be in. I've done it already and I'll paste this whole variable into the description of the video. There are two, one for soft hands and one for hard totals. So we have these massive variables with every decision. However, we don't have a basic strategy for the values of the player's hand being less than 9. But when this happens, we will automatically go for a hit. To start, we will set the action to an empty string as standard. So first, let's create the key we're going to use. Key equals brackets, valuation, and then dealer, colon, -1. Using an if statement to separate out if we are going to use soft totals or hard totals, then inside these is basically the same with the variable names changed. So let's try to use this key. So we're going to use our first use of try and accept. This is so we have the case of those lower values. It won't cause an error and just pass instead. So using this, we try to get the value by doing action equals hard_strategy key. Then if it fails, we accept the key error and just pass through it. The same for soft strategy, but change the variable. If action after this is still empty, then we know it has a lower value and therefore just set the action to hit. There is, however, another reason we want to change the action to hit. You can only double on the first choice. So for our game, we're going to say that if the action is double, but we already have more than 2 cards already, then we will hit instead. Now that we will have what action we're going to do, let's program in these actions. Starting off with hit. What we will do is just use our take card variable from previously, placing in our cards left and our hand. Next is stand. Stand will just return like before. We give the value, cards left, and if we double down, false. Finally, doubling. We want to take a card like previously from here, then grab the new value of our hand before then returning like before. But this time, the doubling boolean is set to true. Perfect. So now that this is done, we can do a little test. Using a pause, we can see our player's hand playing perfectly to basic strategy recommendation. Before moving on to the NPCs, which is more or less the same, just to make the double down work, if we have double down, then I'm just going to set the bet to bet times equals 2. Now, we're getting into the other players. This will be the exact same as before, but we don't need to worry about doubling since the player's bet amount has no effect on us. So to begin, we'll be running the NPCs. If the dealer didn't get blackjack, then we will repeat the function for the number of players we have, which for our code is 3, denoted by the variable p. Now we're going to call the NPC function. This function is the exact same as the player's function, except for this time we only need to receive cards left list back. So asking for cards left back, we're going to call the function, sending in cards left, current NPC's hand, and the dealer's revealed card. Here is the function, the exact same as the player's function, but on the returns, we are just returning the cards left. Now that everyone has had their go, it's all left for the dealer to see how much money he can win for the casino. The dealer goes by a very strict rule, and the rule we will be using for our simulation. The dealer will hit on a value of 16 or less, or a soft 17, meaning a 17 but with an ace. So, to repeat until we are done, we will set a variable done equals false, next to loop with while not done. Inside here, first getting the value of a dealer's hand using our function from previous. Next, we will check if the value is soft 17 or 16 or less, if valuation less than 17, or soft and valuation less than 18. Now, inside here, we will hit with the dealer using the take card function as before. If this is not true, then we will set done to true. So therefore we are done and can finally finish this game and hand out the winnings. Since it only matters to resolve our outcome, we will again just check that blackjack hasn't already happened, otherwise our outcome will already have been resolved. So now we got to go through the 3 potential outcomes. First, we win. This will be checked by if our amount is greater than the final evaluation taken from the dealer earlier, or if the dealer busted, so greater than 21. This can only happen if we didn't bust as well, so we will be adding on amount is less or equal to 21. So if this does happen, then we win, so we will increase our money by the bet. If we have the same valuation and we didn't go over 21, then the game is a draw and nothing happens. Pass. If all of this doesn't happen, then we must have lost, so else we will take our bet away from our total money. Perfect, that is all done, and we have got a simulation of a game of blackjack. Now, since we have our simulation complete and going, we can run it to find the extremely disappointing outcome that you will inevitably always run out of money, no matter what you do in this case. Now, make sure you understand everything from this video. We went through a lot in this video, and it's important you understand every step of this code. This is going into our next video. We will be adding splitting into our code so that we can finally finish this simulation to have every action that a player can possibly do in nearly all games of blackjack. I hope you have enjoyed today's video, and thank you so much for watching. If you did enjoy, please support by liking this video and subscribing to my channel. I hope to see you in the next video.